Hi guys, so recently I was playing with this e-ink display. So I was fascinated with this display because this display doesn't use any power when there is no update in the display. So it uses power only when it has to update itself. The information which has to be displayed when there is no update, we can disconnect the power, and the information which it was showing earlier and still stays lit when the power is off. So it's a very energy efficient display, I would say. uh, and this works with the principle of it has a lot of charged ink inside it, inside the layers, and this charged ink is moved out, in and out from the display in the different layers, so that the the information is displayed. So this has to be driven using a driver board or a hat. uh, Basically this hat generates high voltages to onto the ink, so that the ink can move across the layers and the information is displayed on the display. And when we switch off the power, the ink stays where it was earlier, and the information is still displayed on the display. So I was playing with this for a couple of days, and uh, I was thinking to make it as a digital calendar, displaying some weather information as well as date, time, etc. As you see here, moon phase and current weather conditions. So the hardware setup is very simple here. Display is connected to hat with the flex cable, and the hat is connected to my ESP32 here through couple of wires, and the communication protocol is SPI, and through SPI the ESP32 is sending information which has to be displayed on the display to hat, and the hat sends the high voltage signals to display for moving the ink, so that the image or the information is displayed. So the working of this whole architecture or whole system is the ESP32 connects to my Wi-Fi and downloads the information which is required for displaying on the screen, and it will send it to hat, and further it will be displayed in the display. So basically what I'm trying to display is date, time, temperature, what is the weather condition tomorrow, and moon phase, as you can see, and at the last you can see last updated when this information was updated lastly. So the next question is from where do we get this information, all this information? So there is a very nice website called OpenMeto. So this is the website, how it looks like. So this website is a website where we can ping it and ask for the information, and this will give us the information which we asked without any API key required. As you can see here, it's written as no API required. And yeah, so it's very user friendly website. We can have many parameters could be requested, and it's very simple to use. So it's a free to use without API keys or any software license or any commercial. I mean, it's free to use for non-commercial use. So next, coming to the code, I'm programming my ESP32 using Arduino here. So maybe I'll start displaying. Maybe I'll explain how the code works here. So some of the uh, constants here are listed out, and this is the uh, link for the website OpenMeto, and all the information which we need, we have to list it out here in a particular format, so the required data is pushed back to ESP32. This is the bit where we get local time, and we store this local time in our ESP32. Once we have the weather description from OpenMeto, it has to be decoded as like, I mean, if the case is 0, weather code is 0, it's clear sky, and other things are listed here. Next is the dynamic calendar. So once we have the date and time information from this bit here, we can able to draw a dynamic calendar uh, on the display. So this bit is responsible for drawing a calendar on the display. So here's the calendar, and the current day is highlighted in red. And yeah, so these are the some of the constants which is used for determining the spaces between the columns, rows, and so on, so that the space or the size is fits on the display. Right, so next is moon phase. Again, from the time info here, we could able to calculate what should be the current lunar phase here. So this bit of code is used for calculating the moon phase and displaying this. The next bit is used for displaying the moon phase, or the drawing the moon phase, which is here. Right, so next is some outlines, some borders, blah blah blah. Yeah, so here we now come to void setup. Again, a couple of constants or variables which we have defined here, and this is where we are connecting our ESP32 to my Wi-Fi here, and printing some confirmations like connected or waiting for network time here. Yeah, so once we have the network time, once we are connected, we ping, or we try to connect to OpenMeto to HTTP code here, and the data is handled by JSON document doc here, and again the whatever data we got is linked to all my variables here. So currently I'm getting data like current temperature, humidity, wind speed, weather code tomorrow, today maximum temperature, minimum temperature, tomorrow maximum temperature and minimum temperature. Yeah, next this bit of code is used for initializing the display through hat. The first bit is to get enough memory in RAM, so all the pixel data which is used for displaying the display or the information is gathered here in this segment. Then we are having so once we have the memory, whatever memory size we need is acquired, and after that we start drawing or start filling that RAM with whatever information we need. So here I am calling the get weather description. Yeah, the clear sky, partly cloudy, whatever, based on the information which we received from OpenMeto website. Yeah, here is the bit where we draw the weather icon here. So as of now it looks like partly cloudy here. Yeah, later then there is a couple of rectangles drawn, or some text, moon phase. This text is here. Yeah, moon phase text is here. These are the coordinates for the text in my display. And yeah, there is time is displayed here, last updated display. Last updated information is displayed at the bottom of the screen here. Yeah, so there are some more things like temperature, humidity, temperature maximum. All these are codes which are used for displaying all this information on the display here. Yeah, so what is the weather tomorrow? Get weather from website for tomorrow's information and write it on display. Next is drawing the dynamic calendar. Dynamic calendar is what I have explained earlier. We get a weather. We have the date information. From the date information, we can effectively draw a dynamic calendar for that particular day. That particular month. And after that, once we have displayed all the information on the display, we put the display to sleep. So because we don't want to continuously power the display, which going to cost us the power and or the battery life of it. Once the display module is goes to sleep, then we call the function for the sleeping of ESP32 also. And every one hour the ESP32 is going to wake up and run the code again from top to bottom, whatever I explained, like connect it to my Wi-Fi, go to website, get data, and store this data and send it to hat for displaying. Or rather, before sending, there are some calculation involved, such as the ESP32 has to determine what is the current moon phase, and it has to draw a dynamic calendar and then send the information to the hat for displaying. And in the void loop there is nothing, because before getting into void loop, ESP32 goes to sleep, and when it wakes up, it will start from the scratch. Yeah, so this is the software or the code on which it is working. So for the weather icon here, for displaying the weather icon, I will get a weather code from OpenMeteo website. Based on the weather code, I have for each weather icon I have X data here, basically 4 color data representing the weather icon here. So basically ESP32 will pick weather data according to these weather conditions. The documentation for this display is quite well documented. This display is from a company called WaveShare. So let me go through their website or a page where the documents or the how to drive this display is clearly documented. So it's a WaveShare website. My display is 5.83 inch. It's a SPI communication protocol, and these are the sizes. Resolution is 648 by 480. Display colors are 4, as we discussed. And yeah, so the documentation is quite extensive. It's really easy to understand, and this can be driven from any of the microcontrollers, ESP32, Raspberry Pi, Jetson Nano, or yeah, the list goes on. And and the libraries are given. You can download the libraries, connect the display to your microcontroller as it's listed here, and the setup is very easy, and there are many example codes or example bits uh, where you can use it, and you can start displaying whatever information we need. Yes, so yeah, again, a pretty interesting display which doesn't use any power when it is switched off, or uses power when we only want to refresh the data on the display. Yeah, I am planning to hang this uh, display on my wall, so that I have a digital display which I don't have to change every month or every day, and the informations from the website is directly displayed on here, and it's updated every hour. Thanks, guys. See you later.